All right, everybody. Tonight we're going to be talking about Unit 10, and we're going to be talking about Python libraries. Um, Arguably, probably one of the most important libraries that we're going to talk about is the one that's at the very top of the unit folder here, which is what the one we call matplotlib, right? So it's the mathematics plotting library. And you can see just from the little, screenshots that we have there, examples of the kind of output it can create. So like anything from like simple like line charts to curved shapes to like 3D renderings and stuff. It's all a matter of like the data that you feed into it. But it's all done through Python code. And that's what's really kind of fascinating about this. Before I look at that particular link, I'm going to look at the second link here, talking about the Python standard library. And this is from the python.org website. And now there's some reasons why we call this the standard library. There's a lot of commands in Python that we do that are built right into the core language library. So just for example, commands like print or if statements or function definitions and things of that nature, that stuff is part of the standard library reference. However, there's a bunch of different libraries that are also attached that are libraries that are considered standard libraries that you don't necessarily have to call in, and some libraries that you do have to call in. So like when you see like these definitions here where they have built-ins, those are ones that you don't have to call in. So like for example, when you're working with numeric operators or variables or anything like that, those are built in, right? So these are all like things that are built into the language that you don't need to call a library in to have it operate. However, there are things that are part of Python that you have to call in the library in order to get it to execute the code. So in other words, they don't add the overhead of those libraries to the standard language library, but they're standard parts of the language that you can call in. So like when we get down to the sections here, like where I'm starting to reach right now, where they start talking about certain types of activities. You notice how they have it broken down into categories, right? Like, so if you're processing text or you're working with binary data or different data types that are weird or weird math things or programming and file access, et cetera, et cetera, et cetera. These are all libraries that are part of Python, but you have to call them in to perform the operations. And all of them have basically a collection of methods and tools built into them that do particular actions related to the kind of thing that you're programming. Okay, so the ones that we're kind of interested in here, right? And some of these you'll notice maybe we've already played with. When we start looking at like data types and things like that, you'll notice that some of these are ones that we've called in. So like the math libraries we've called in and the random libraries we've called in. Um, Other things that we start to get into, like here, when we start working with really weird, obscure stuff, and I'm just very quickly scrolling through the list here, and you can see all the different types of processing things that are available here. Everything from like processing like graphics to scraping web pages to creating graphical interfaces, like some of the tkinter stuff that we did last week. And These are all ones that are already there. You just have to call the libraries in and then use the tools that go with them. All right, so I'm just kind of scrolling through that so you can see all of those. And folks, I'm going to pause here for just a moment. Okay, so that once again, this is a really handy reference if you want to dig in and figure out some of the tools that are available for Python. And normally you don't use these tools unless you have a specific reason to use them. It's kind of the general advice that I give about the Python standard library reference. One that is really particularly important, though, is the matplot library, especially for the kind of work that we do in data analytics and artificial intelligence, right? And this is the ability basically um, to take information and present it beautifully and graphically as a chart or a graph. And now we've demonstrated this tool already a little bit, but we're going to learn a little bit more about it. But I did want to show you this website here. So that's the one that's linked up right at the top of the unit folder. And if you were to want to get in here to do very specific graphical tasks, this is a really good resource because this is the the organization website that runs this library and shows you how to create all the different types of visualizations relative to the stuff that you're doing that you need it for. They have a bunch of different examples here. So like I'm just going to click through a couple of these. Okay, so that's not the link that I wanted. I apologize. It's this one here. And they give examples not only of like the code that you would use to generate something, but all the different types of visualizations you can get and examples of them, so you can get inspirations. One of the things that you will notice as you're working with these libraries, and I'm just going to do a couple clicks of zoom here, is that you're always going to be importing very, very much at least the core library itself. Sometimes you're only pulling in very specific tools out of the library, and that's kind of a subjective thing. And in this case, that's what they're doing here is they're pulling in pyplot, which is one of the tools inside of matplotlib. And notice again that they're doing a little bit of a aliasing here, right? So they're aliasing the information. So in other words, they're calling in this library, and in order to utilize this tool, which normally you'd have to put that whole statement in there, they're abbreviating it as PLT. So that brings the whole power of that library in with those few letters. I often see programmers even just using a single letter sometimes to represent a library. It just depends on what other stuff you're doing in your code, right? If you're doing a lot of libraries, it might be a few letters. If you're just doing one particular one, you sometimes just call it a letter. And then that way, when you're writing your code, you just refer to that whole thing, with this little acronym. And then ultimately what you're really doing is you're pulling in methods or really functions from those libraries to do the plotting. In this case, they have another library they're pulling in. So they're pulling in numpy, which is one of the math libraries. And what they're doing is they're using one of the tools inside there to basically graph this equation, which is a nonlinear equation, by the way, because it's got pi in it. So it's got geometry. So it has a curvy shape to it. They're getting the equation to run. They're giving it a sine wave, right? And that's getting stored, right? So they have this a linear space and then a sine wave shape. And then they plot it on the screen and they show you the commands for doing it. So this is just an example of one simple tool to generate one graphic. Some of the graphics that you can create with this library, by the way, are static. Like this is a static image here. So in other words, it generates the image and there it is. And then you can like add it to your app, like if it's a GUI app or a console app, or you can generate the graphic and then capture it and put it in a document. But matplotlib also has the capability of creating live interactive graphics too. That gets a little bit more complicated, a little more programming that goes to it, but it is entirely conceivable. As you kind of look through their, various tools that they have here, you can kind of like dig into like, a bunch of different kinds of examples that they have here, and with complete documentation, tutorials, and all that stuff is all available on this website. So I would encourage you to explore. So for example, like if you're trying to create like graphics that look like this, they'll have very specific examples on like how to get like this kind of data, right? With the math equations and the whole bit. And you see, there's not really a lot of code that it takes to get there because the backend libraries are doing all the work. That's really what's going on. But what you will notice in common though is that you do need to have mathematical equations that you're feeding in, right? If you're starting without a data set, and so this is one of the key parts of it. So if you don't have a data set, you're generating a data set with math, or you're generating data with mathematics. If you have a data set, you usually read the data set in and then feed that data into the graphics tool, usually as a list or a tuple or a dictionary or something like that. And then it reads that data and then interprets it and puts it where you tell it to put it. So whether it's on the x-axis, the y-axis, or something other. Okay, so I do want you to notice how they, like with all their examples too, and I don't know if you guys are picking up on this, but they have, like, if you see a really cool visualization, for example, they have the code for it. You can download it either as a regular Py file or a Jupyter Notebook file, or you can grab the zip if there's data that goes with it. So I would encourage you guys, to explore that if you're indeed intrigued by it all. But that's really a useful resource. It's not one of those tools, by the way, that I would expect that you would ever like get to the point of memorizing. So generally, you're looking up references as to how to use the library. Typically, whenever you're using it, it's not unusual. The other thing that I point out here is we do have this link, which takes us to a LinkedIn Learning course that talks about Python standard library features, like what stuff is built in. And the lady that does this course has a whole collection of videos on a bunch of different topics and explains how those are all handled, right? And you can see some of the topics here that are available in that video. So everything from working with operators, and that's kind of stuff that we did in class. And then, things like range and list and round and some of these things we did in class, right? So you notice some of these things are just kind of normal. And then we also get to these higher end features here towards the bottom, including like scraping stuff off the internet or taking data files and either converting them to JSON or retrieving data from a JSON file, which is a very common data transmission format. And there are tools within the Python standard libraries for dealing with those issues, right? As we saw on that one website. So this is really useful because a lot of it is demonstrated and it's done so on, I'll say, on a gentle level. So you get the idea. So if you want to like recall how to do those things, at this point in your Python career, you switch from like, hey, this is how you do Python, to like learning how to look stuff up for Python that you need to do the tasks that you need, right? That's one of the grand takeaways. Now, in terms of some of the libraries that are very specific for data science, I had this list here before, and I ended up revising it because it was linking to an article that was no longer available. The publisher took the article away, and so I rebuilt the content from it, and then kind of categorized it a little bit too. So some of the I call this like the top 10 libraries for data science, and it's kind of broken down into various categories. So you'll notice, for example, some of the core ones that we work with. So these are ones that you eventually will utilize. And you see, I should probably have a space here, but NumPy, Pandas, matplotlib, I'd call those the big three, but Seaborn and scikit-learn are ones that are also very useful for doing data science. I want you to notice that with the descriptions here, they kind of explain a little bit what these libraries do. And normally, how do you know which library to use? And I'll say that generally, you'll find other examples of like people doing work and they're like, oh, they use NumPy. I'll try NumPy and see how that works, right? There are libraries, by the way, that kind of do similar things and have overlapping features. And then it's just really kind of like what collection of tools you're doing or what specific tasks you're doing that kind of direct you to which specific library you're using, but these are some of the big ones for regular data science. When you're doing machine learning and deep learning, here's probably the big three there. TensorFlow is certainly probably one of the bigger ones. We also have PyTorch and Keras, right? And I think I'm saying those correctly, by the way. And those are very popular ones for those activities. And then when you're doing regular straight up statistical analysis and visualization, so in other words, creating graphics out of stuff, these are tools that you often use too. So you notice like the plotly thing at the bottom there, but all of these can be used. All of them have different syntax and tools. And once again, you usually base which tool you're using based on examples that you've looked at that seem to get you to the right place. People that work in this field and code a lot of stuff in Python and use these libraries a lot get very attached to very particular ones. So they that basically what I'm trying to say is that becomes kind of dependent on the activity that you're doing and the experience that you have working with any of those things. All right, where I'd like to go next is I do want to dig into this one example here. So I'm going to dig into our old textbook, and then I'm going to code through this little exercise here. And I think I have the sample code pulled up. We'll see. But you guys, if you don't have your old book, no sweat. I will pull up my copy on the screen. And we'll look at that particular little item. And I do have this also pre-recorded. So I know this is like double recording it now, but I'm going to walk through that. So it says this is, I think, chapter 3 we want to go to. And they have a little link here to Toolbox 3.2. So this is where we're going to. And so what I'm going to do to start is I'm just going to kind of read through this really quick to explain what we're about to do. I may end up pausing the video for a second while I queue up my code, and then we'll code through that. What I also do want to point out is that this zip file here contains all the sample code from our old textbook. So like anything that's like in the chapter, like in the readings, that code is in that zip file, including what we're about to do here. And so, I mean, that's why this is not really an exercise. It's more of an example to kind of get our feet wet so we see how it operates. All right, let's read the description. And it says, a graph provides the visual representation of data by showing the relationship between sets of numbers. The matplotlib module provides a collection of easy-to-use tools for many types of graphs, and we'll explore a few of them. So here's an example where it says you've been offered a job in Fairbanks, Alaska, and you're considering whether or not you're going to accept, and you're a little concerned about the climate, and this is how warm it gets on average each month. So these are average high temperatures in that town. And you can see that during the winter months, it is quite cold there. Those are the high temperatures, not the lows, right? And even in the middle of summer, it usually doesn't get much higher than 70 degrees on average. But you notice that there's a correlation in the set of data. We have a month and we have a data point, right? And these are temperatures. And it says you can try to scan through the numbers to make sense of them. And some of you can do that and go, okay, well, I see it starts low, it gets high, and then it goes low again, right? That's pretty normal. But a visual is a lot more useful, right? So this visual here shows the average high temperatures in a chart format. And you'll notice that the scale goes from 0 degrees up until 80. The months are listed on the x-axis, the temperatures are listed on the y-axis, and we have a nice little chart. And that's a lot easier to look at and figure out how warm it's going to be or which months are warm because you see it visually, right? And that's really kind of the point of a visualization in the first place, because looking at a collection of numbers, maybe your eye can see that in the numbers, I would hope, right? But if not, a lot of people need to see it as a picture to have it resonate more. And that's one of the reasons why we even do visualizations in the first place. Now, just for the sake of kind of doing this quickly, because I don't want to dig for the code on this, I am going to grab that zip file, and it's downloading right. Oh, I'm grabbing it twice. Great. And I'm going to unzip it. I know I have this already expanded, probably in one of my other folders. And I do want to go back to the book here for a second, right? So they give us an example here. So they give us the steps to build the code right here. And so you can follow that to create, the graphs as you see them. I do happen to have the Fairbanks one already created here. So I'm going to extract my zip. And actually, the author already has it created. So I'm just got to give it a second. So waiting for the zip to unzip rather than going to look for the files, which I know I have somewhere anyhow. That's how it goes sometimes. All right, so now I have my code available. I am going to bring up Spider to do this coding, just because I think that'll probably be the easiest way to give the example. And I will show you how the author did this. And I'm going to do this with a bunch of copy pasting rather than code it from scratch. You guys can code along if you wish, or you can unzip the same files if you wish. But I'm going to create a new file, and then I'm going to do a save as on it, and I'm just going to call it Fairbanks .py, and then I need to put it where I normally put my work. So I will put that here. And that's going to go in this folder here. All right, I am going to zoom in because I know you guys probably can't see that. And I'll zoom in over here as well. Now, the first thing that we're going to do is we'll do a little bit of a description here at the top.
Excuse me, do we want to use the share site that we used the last time?
Martin, I'm going to refrain from doing that because the code for this is in that zip file.
Oh, okay.
All so right. If you download the zip file, unzip it, go to chapter,
it'll be there. Perfect.
Okay. And then find toolbox 2, you will see the code there. All right. So one of the first things we have to do is bring in the library. Okay, it's not the first thing I'm going to say here is I'm not abbreviating the name of it, but I'll do that later just to show you. But from the matplot library, I'm importing pyplot, which is their main plotting tool. The other thing that we're going to do is we're going to take that information from the book, and we're going to list out all the average high temperatures. And you see what I did here is I just took each particular month, right? And I just took the temperatures as a floating point number and put it into a variable with the name of the month. That's how I'm choosing to do that here. All right. So that's just my raw data. Now, truth be told, I can, instead of code share, by the way, I can just put this in the chat, right? If you guys really want to, code along. The next thing that we're going to do is we're going to take this and we're going to use the bar chart tool from pyplot. So pyplot's a subpart of matplot library that creates bar charts. That's one of its things. And you can see how we're feeding it in. So everywhere here where we say pyplot.bar, then we're feeding in parameters, and the parameters are the order of the data, so 1 through 12 for each one of the months. And then that January, February, March, April, blah, 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 all that stuff is actually the actual temperatures that we see right there. Now, that's our raw data set. So that's going to tell it that at position 1, chart 1.1, at position 2, chart 10, at position 3, chart that, right? It just follows the month one at a time. One of the big concerns, of course, if you're living in Alaska, is when is it above freezing and when is it below freezing? So we're going to draw a line across the graph that indicates the freezing mark. And they're starting here with a couple of pieces of data. And you notice the one that really makes sense, right, is the 3232. So what exactly is that going to do? Well, we'll see it when we put it on the screen, but it's basically going to draw a line on the screen that shows us where that freezing mark is. All right, next thing that we're going to do is we're going to start to format the display, right? And we'll do this one at a time. So every time we're doing like anything in PyPlot, often we'll have a title, right? We'll have an X and a Y label. So we label both axes, and then we have this thing called ticks. So in other words, um, uh, the markings that we're going to throw in um, on the chart is kind of the best way I can list it. So in other words, when I put the information on the screen, and I want you to notice back in the book here, if I can find it, and we'll zoom in on the graphic here a little bit. So here's the 32 line, right? The dashes. You notice that the ticks at the bottom, so ticks are the markings on the screen, right? And the ticks at the bottom are January, February, March, April, May, right? So we need to feed those in as a data set. And then the ticks that go on the other axis, and this one I'm a little confused with why they did it like this, and I'm going to show you the code. But what they're putting in as ticks on this are all these numbers. I'm not sure why there's a 0.4 on all of these. I'm not really quite sure. So we'll see what the output is. But you'll notice that this is two lists fed in. One is obviously the bottom one is the months. That'll be pretty evident. All right, so how do we get to see the result of this? At the very bottom, we just type pyplot.show as a method, and it will show what we've created. And did I spell that incorrectly or something? I think I have broken syntax here. No, that looks good. All right. So just a reminder, when you're in Spider and you run plots, they appear in the little plots window in the top right panel. So I'm going to go ahead and run this, and we'll take a look at what it creates. And there we go. All right. So this is kind of weird, right? Because these ticks here don't necessarily match up beautifully with the ticks in the temperature area. And what we're kind of looking at is, okay, first of all, the 32 line that goes across and the 0 to 14. If you're wondering what that is, that's the bar position. So it starts at one position before the first position and one or two positions after. That's why it keeps extending out, right? So that's why it's 0 to 14, but we have 1 through 12 here. So the 0 is here, the 13 and 14 are here. As far as these numbers go, I'm having a hard time figuring out what these numbers are exactly about. And so I would start reading up on it to figure out why it's doing what it's doing. Yeah, so I'm not really sure what these numbers are representing. And one of the ways to figure it out is to just very simply change them. I do think it's fascinating, though, that the y axis is basically sort of auto generating itself. And how is it auto generating itself? Well, based on the values that we're feeding in up here. So it recognizes that the highest value is 72. So it goes just a little beyond that. It recognizes that the lowest value is 1.1, so it doesn't take us below 0. So this scale is kind of auto-determined, is the point. The best I can figure is maybe these are relating to colors. And I'm being very, very speculative here. But that's one of those things that I would say we probably want to look up. Maybe that's actually written in the book, and I should just look in the book and it would give me the answer. So let's see if that's really the case. Right, and see, they give you a very simple example here. Okay, so maybe it has to do with the width. I think of the data. Okay, so I think that's what it has to do with. And
Well,
notice
where
how they
did
did a much more simple version of it here. So you could do it like this. I see I have a question there, Christina.
It's not a question. I tried taking that point 4 out, and all it does is it moves the tick mark for the month into the middle of the bar instead of to the right of it.
Ah, gotcha. Okay. So that just determines the positioning of the tick mark. Okay,
where
that
did the
makes sense.
colors come from?
The colors, I think, are randomly generated
Mm,
by the bar chart engine.
okay.
So I think after a while they would probably repeat. You know, if you, and I don't know if that happened in ours or not. So like if you look here, looks like it goes through an array of like 8, 10 colors, and looks like orange starts to, okay, blue, this shade of blue and that orange started to repeat. So if we had more data, it would probably end up repeating. I could force all the colors to be one color. But I want you also to notice here that even from a very simplistic standpoint, like I put variable names in these positions, but you could have just hard coded the numbers and created the graph. So that's an alternate approach. Right, so that's our little sample exercise. So now let's turn our attention to the real exercises and kind of move on with that. All right. So now we're going to do this bubble chart. So I'm going to actually click in on it because there is a document and some data here to pull. So the one thing you'll want to do is grab the data, right? And so there's the data, it's a text file. So here's one of the tricks here when you're working with a data file like this, it's just a text file because it will just load up in your browser like that. You want to right click and save link as. And I would recommend just dropping it into your folder for this unit. That's what I'm going to do with it. This is unit 10. So we're just going to save it there. And then we also have this document here that we're going to pull up to help guide us and explain what the exercise is. So let's take a look at the explanation here. So our goal is to create a bubble chart showing the relationship between cities and ghost sightings using the attached data. Now there's a speculation here. Some reasons behind ghost sightings could be due to electromagnetic fields or reactions to toxic substances in the atmosphere. And then Christopher, who put this together, has a little hint in there. I used 500 as the Z value for the size of the bubble, just to make the bubble a little bit bigger. So one thing that they're going to plot here is they're going to look at toxic stuff in the atmosphere versus magnetic fields, and then where the cities land on that chart. So we're going to create something that sort of looks like this. And then you'll notice that's all the instruction that we actually have. We don't have more instruction on this. So this is where you start doing a little bit of research basically on how to create a bubble chart with Python plotting. Now, of course, I do have solution code that we're going to pull from, but like if you didn't have that solution code, how would you figure it out? And the answer would be you would start researching how do you do a bubble chart with this library, basically. And so I'm going to pull up my solution code here, and then we'll start to build this. All right. So I'm going to first go back over to Spider here, and I'm going to create a new file. I'm going to go ahead and do a save as on that. We're going to put it in the same folder here, and I'm just going to call this ghost.py. Okay. We were given a data file, and I think it's probably pertinent to look at that data file. So let's go to the folder. And I'm going to pull the folder over here. And we'll look at the ghost data text file. And this is just coming up in Notepad, by the way. But it looks like basically the way the data is structured, and this is, kind of interesting data. It looks like we have the name of the city, a two-letter state. There's a comma space in there. And then we have one set of data and another set of data. And I can assume the one set of data is the electromagnetic field, the first set, and the second piece of data is the reactions to toxic substances in the atmosphere from the citizens in that area. And I think it's kind of interesting when you look, this is built on real data from somewhere, right? So there's different magnetic fields in different towns, and there's different toxicity levels in certain towns. And then as you kind of look down the cities here, it's really kind of an interesting data set to see, like, is there a correlation between like weird places and those kind of activities? I do find it interesting that out of all these places, Chicago is the closest one to us, right? And the magnetic field's kind of low, and so is the toxic stuff in the atmosphere. And I suppose that changes when you go near the factories in Chicago, but maybe not. I really don't know. But that's the breakdown of the data set. So the assumption is 2 lines here represent the data in the file. So that's an issue we have to work with in terms of reading in that file and processing the data, is the format of the data itself. So it's city, comma space, 2-letter state. And that's probably not, because that's probably just a label at this point. But then that's followed by a line of one piece of data followed by another piece of data. That seems to be a space or a tab. I'm not even really sure, but it's one of those. Okay, so that's what the data looks like. And always, whenever you guys are processing data in a raw format, whether it's feeding into an app or whatever you're building with it, it behooves you to look at it and know what it's doing. Now, what I'm going to do up here at the top is I am going to paste in the instructions that I had in the document. All right, so, all right. And I do want you to also notice that this is similar to the bubble chart on worked example 3 on page 354 of the books. If you want to go hunting for it in the book and find the example, you can do that if you want, but that's the tip that I give. All right, so we're going to start by importing the library. So we're going to do from matplotlib import pyplot. And I might, during this one, I might alter it and use an alias, but for right now, let's just leave it the way that it is. Okay. The other thing that we're going to do is we have to determine a size for the thing that we're going to output. And this is just what we did last time. We made it 8 by 8. So I'm not sure exactly what that means in terms of pixels or whatever, but that's the size that we went for when we built the exercise. All right, so I'll throw those 2 pieces in the chat for right now. I just don't want to type them. All right, so next thing that we're going to do is we're going to be processing data from an external file. So let's load up that data. Let's first create a variable called infile. and we're just going to open the file. Okay. You guys are noticing here, I don't have a read or write designation on the file. So how is it coming in? Is it coming in as a read only or coming in as a writable file? Yeah. If you're not sure, you don't know how to answer it, you could guess, right? If you were to open a file and you weren't designating whether you were reading or writing it, what would be your guess as to its readability mode?
Read
I think
only.
read only is a safe guess, right? Yeah, that's a safe guess. Right, so we're opening the data file and we're storing it here. Now remember, a text file, the way that it comes into Python is it's a list of lists. So each line is a list of characters or strings. And each line is one position in a list of all the lines in the text file. So we have a collection of lines that are a list, and then each line is another list with all the characters that are there, whether they're numbers or spaces or punctuation or whatever they are. That's how it reads in. All right, so we're going to have to process some of this stuff. So in other words, we have cities to work with, we have magnetic fields, we have toxic atmosphere, and are there any other data points on this? I kind of feel like there's another data point on this in looking at it. So let me go back to the Word document. And I think that's basically it, right? So I think that's all we really need for that. Okay, so what that means in terms of our data here, if I'm going to read in all the cities, I'm going to turn the cities into a list. So I'm just going to create a variable called cities, empty square brackets. I have an empty list. Next thing I'm going to do is I'm going to create a variable called magnetic fields. Also going to be an empty list. And then toxic atmosphere, also an empty list. I did notice that, and this was apparently done by Christopher, had one more list in here, but as I looked through the code, I didn't see any spot where that data was used for anything. So I'm going to be omitting it right now. So I think that's kind of interesting that he had one extra field in there. All right. Next thing that we want to do is we want to read through the data and think about how we'll read through. So like, this is why it's helpful to have the data to look at. We'll read through it line by line. First read is a city, right? And then we get the two data points, and that's got to be split. That information has to be split apart. The city could be dealt with as a whole because we don't need to separate the city from the state. We just think of it as like one thing. New Orleans, New Louisiana, for example, is one entity. So we'll just treat that as one. But the two data points have to be set up as two different entities, and we use the split command to do that. So that's going to be reading the city, reading the line, splitting the data, and putting it into two different things. And then we're going to take the data that we split apart, both the city and the magnetism and the toxicity, and append it to the lists with the appropriate names as we kind of go through the file. That's the procedure. So right now, the task is basically to populate all three of these lists with that information. Now, that is a repetitive process. And the way that we structured this last time is we started with a while loop. And some of you might say, well, a for loop might be better. Yeah, perhaps. And this is just kind of also to teach you kind of a lesson on how to kind of build a while loop to do some of the same things the for loop does. And you'll see like the syntax here, while not done, right? What's done? Well, done is basically a Boolean value that we're presetting to false. So while not done, when we start, it's true, right? So you see, I'm setting it to false. So when it hits the loop, it will run. And if I get to the point where I'm done processing all the data, then we can flip it to true and we pop out of the loop, right? And how do I know I'm done with the data? Well, when it gets to the end and it doesn't have any information in it, that's how we know we're done, right? So for example, if this data set had a break in the data somewhere, that would trigger us off. So this is continuous data, so it won't trigger us off until we get down here. So first step, I'm going at one indent level in here, is we'll populate a variable called city. So we're going to read one individual line. So we're going to say in file dot read line, and that reads the first line in the file. All right. So the first thing we're going to check, if that line that just got read in happens to be blank, then we're done. Okay, so we're handling that scenario right off the bat. So if it's blank, we're all set. Move on, right? Pop yourself out of here, out of the loop. All right. If it's not, here's where we start reading through the data one line at a time. So reading first line. So the first line will get stored here, and we're going to do that by taking the in file and doing a read line on it. Right, so it reads that first line, and that first line we know is going to be a city. So we're going to say cities.append. And what are we appending? The city that we just captured, the line that we captured up above, right? So it's captured here, but we're processing it, appending it to the cities list here, right? Then we're going to break the next line into parts. So I'm going to create a variable called parts, and then we're going to run the split command on it to separate that data into two data points.
Time sensitive, I talk to you right now.
Aha. So now I understand what the question is. You couldn't hear me, so I apologize, but I'm flipping my camera and mic off. So let me just do a little quick repeat of what I just put up on the screen here. So before we went to the brief little unexpected break, we had split our next line that we're reading into parts. The parts, and the way that will happen is it'll read the first piece of information, recognize the space to do the split, and then see the second piece of information. So this is position 0 and position 1 in the parts list. Then we take the stuff that's in those positions, we convert it to an integer, and we drop it into a temporary variable, and then that variable is then appended to the lists above. So now we're building a list of cities, and we're building a list of magnetic fields and toxic atmosphere data points. When we reach the bottom of that data, it'll recognize that we have a blank line. We'll switch done to true, and then we'll pop out of the loop. Right. Could have done this with a for loop too, but this is just an example using a while loop just to show you that you can do it. All right, so next part is, now that we have the data and it's put into a bunch of lists, the lists are very useful then for constructing the bubble chart. So that's our next step. So here's the commands to do that. I'm going to create some blank lines here just to move the code up a little bit. I know everybody's like busily trying to copy this, and yeah, I'll do you the solid here. Copy this data over for you. It's coming in the chat. One of the benefits of showing up to class, right? The copy pasting of code. All right. So to actually construct the bubble chart, the bubble chart really is a type of a scatter plot, really. So a scatter plot is where we just put dots on the XY axis. And the way that we make them bubbles is by feeding in one of the parameters to make them bigger. And that was where that 500 thing came in. And so I'm going to drop in this whole command, and then we'll kind of break down what it all means. So here's the whole command, right? So the first data point we're going to feed in is the magnetic fields. That's the whole list. So that's going to be a list of integers separated by commas. Same with toxic atmosphere, another list separated by commas. 500 indicates the size of the bubble, right? And then notice that we also are running this range command with the cities to label each one of the data points. And we start from position 0 to the length of cities. So in other words, it reads in the data point names of all the cities in the list in the order that they were read in, starting at position 0 up until the length of cities, which is one longer than the last index position. If you guys are just wondering what that does. Just a clever way to get the names on there. The other thing that we do is we will run a loop. And Martin, I see you have a question.
Yes. So in the instructions, you have a DA1 Python plotting, and you have you're using something slightly different. You're using a bubble chart. Yes, a scatter plot where you have the dots, the bubbles across the square with the locations of the city, and you do have the same data points, values, but it's slightly different. Just I noticed because
and I'm not sure exactly where you're referring to. So you're saying in the instructions here?
Yeah, see you exactly. You even mentioned the size of the bubbles, 500.
Yeah, that.
I mean, you're still presenting the data. That's fine, but I just thought of.
Okay. Well, thank you for pointing that out. I appreciate it.
No problem.
All right. So going back to Spider then, the next little piece is to get these things plotted, right? And you notice how we're going to plot the text now from the cities next to the name of each one of those things. So what we will do is we will look at the corresponding positions of each one of the data points. Notice they all have the I index number here, basically. And so the data points will all travel together. And then here a color is specified to make them all blue in this case. All right. That one is coming in the chat right now. You guys want to drop that in? Then just a few more commands here. So we are going to do some displaying things. And the first thing that we're going to do is we're going to turn on the grid so we can see basically the lines of the chart. We have a label for the X and the Y. X is in the bottom, Y is on the side, and then a title as well that will appear above the chart, which I think is helpful. And then finally, the pyplot.show command. Now I'm going to go ahead and run this so you guys can see what happens here, but you do have to make sure that the file, this data file, is in the same folder with this exercise, right? So just make sure that you're saving in the right spot and that your data file is present. We didn't set up a try except loop here, but that would normally be a good practice, whenever you're feeding in external files. But the main point here is to get the stuff to display correctly. So let's go ahead and run this, and then you can see the output here as it comes up in the plot thing. And you can see, looks pretty nice. Once again, it seems like the colors are somewhat randomized. There's a grid to help show the tick points on both axes. The labeling, I think, is fairly clear. Some things don't look super great, like the way some of the stuff sits here might be a little bit better, right? But overall, the graphic is pretty good for as quickly as we did it, right? So this is doing the bubble chart. I'm going to move on to the next exercise in the interest of time here. We're just very rapidly running out of it. So let's move on to the next one. And this one is a bar chart. And this one's intended to be funny. And I do have to credit Christopher with coming up for this. The joke is that he's doing various pressure pipes at a manufacturing plant. And it says that basically it should look like what we have below. So in other words, there's 4 different pipes, or at least a main 1, main 2, main 3, and an auxiliary one. And then there's a certain amount of pressure between seemingly 0 and 100. And it says you may use your own data for this. So this is kind of like one of the things that, it's like, how much data do you put in there? Well, it is very relevant. But if you look really carefully at his labels, and I think it's kind of funny, the bottom one indicates the flatulence level, and the one on the left indicates the pressure of that, factory pressure of flatulence, I guess. So he was trying to be funny when he did the labeling on that, and you don't really have to follow that exactly. So I have, once again, some sample code here. And what I decided to do with mine, and in this one, I am going to demonstrate, by the way, aliasing libraries on this example. And I'm also going to pull in a couple of extra libraries. So I'm still going to use matplotlib, and I'm going to use numpy. And then I'm also going to use a random number generator to actually help generate values, right? And okay, so let's kind of dig into this. So this one's a little bit more free form. And so this one you'll definitely want to follow me on. So I'm going to start by creating a new program. We'll do a save as right off the bat. And let's just call this pipe pressure.py. Zoom it in. If you want to copy your instructions over, you can do that. I'm not going to do it. I'm going to start first with my imports. So here come my imports in the chat, by the way. All right, so notice here we are using pyplot again, and this time we're going to abbreviate it as PLT. We're going to use numpy, and we're going to abbreviate that as NP in our code. And we're also going to use the random number generator to help us generate data between certain values, basically. All right, so first thing that we're going to do, and this is kind of a whole separate lecture topic, and I don't really want to go down this pathway right now, but we're using numpy and the random number generator together to do a seeding of the random number generator. So in other words, we're kind of establishing sort of a middle point of the data is kind of a way to think about it. And, you know, and one of the reasons we do this is to, you know, in principle, create values that are kind of similar each time, you know, so 42, it could have been 47, it could have been 53, but you know, if you guys remember, the range went from like 0 to 100, something like that. So we want to kind of keep it, you know, in that range. 42 is kind of in the middle and a little bit on the lower side. That was my thinking on it. So we want to do a simulation of pressure data for 4 different pipes. And what I did is I created a name for the pipes, and you know, like Christopher did, like main 1, main 2, main 3. I'm just doing pipe A, B, C, D. And by the way, I'll give you all of this code here in the chat once again. All right, so there's our pipes named. Next thing that we want to do is we want to establish some pressure values. And so keep in mind, right, like what might happen is you might have this in a CSV file or a text file or a database dump or something, or JSON file, and you're reading it in. In this case, we're hard coding it, but it's going to be a list of data points. And since it's going to be a list, we're going to put it in square brackets. So I'm going to type the square brackets, and I'm going to put my cursor in between and press enter, and then enter my data here in between. And I just want to show you how I'm going to do this here. And basically what I'm going to do is I'm still using the random number generator, right? And we're going to use this uniform function. And once again, I don't want to get really deep into explaining like what this does, but this will generate values that will fit between a range, right? So in other words, we have these pipes and we know normally they're going to operate in this range. And I'm going to kind of set upper and lower parameters of the range, and then I was going to pick a random value in between. This is, you know, so this is my way of creating synthetic data, basically, in a Python program. So for the first one, I'm going to put in the values of 45 and 55. So it's going to create something randomly in that range, right? And then we'll go through and we'll declare all the other pipes. But you know, the kind of the point of this is that it is approximately 50 psi, you know, so it's in a range, you know, that's kind of the thinking. Then I'm going to create 3 more of those, one to match each pipe, right? So these are the values that I had. So for pipe A, B, and C, and pipe D, you know, there's kind of expected ranges of pressure, and I'm just kind of working with these numbers. So we know it's going to be about a certain amount, but we want it to be random, right, to simulate it. I'm also going to move this bracket out, but this is a list here. It's just one that's spread out, so it's easier for us to read. Human readable, we'll call it. If you want to use the same values as me, you can. You can also come up with your own values, right? Another approach to this, by the way, is instead of having this ultimately generate the value. So like, just to show you, like if I wanted to just kind of output this to the screen, I could do this right now, and I could just say print pressure values, right? And it'll just print the list. So I'm just going to run it, and you'll notice the values it created and see how they're random. And if I run it again, the values will not be exactly the same, but all the values will be within the ranges I specify. Right? And notice those are all floating point numbers too. And you know, once again, we know it's going to be in a certain range. We're trying to simulate it. So we're allowing it to do a little bit of randomization so we can get different looking bar charts. But this is how I can prove that it's generating different values. So another approach to this would be honestly just hard coding a list kind of like this. You could do something like that. I don't know why you'd want to, but we talk about synthetic data in the AI class. Here's an example of us creating it with a random number generator. All right. Next thing that we're going to do is we're going to create the bar chart. And all right, so here's where we start to use the pyplot library again. And notice I'm not saying pyplot this time. I'm just using the PLT. And we're going to set up a figure that's 10 by 6 in size. So that's the X and the Y, so a little bit wider than it is tall. Then we're going to set up a variable called bars, right? And then we'll call the command, right? So pyplot, create a bar chart, and then we're going to put the pipe names at the bottom, the pressure values on the side, and then we can declare a particular color for the output if you wish. What might be helpful as well is that you add labels at the top of each bar showing the values for each one of the things. And I'll finish typing this loop here and then I'll share the code with you if you guys are hoping that I do. So my loop is going to start. I'm just going to do a for loop this time. So for every bar in the bars pyplot bar thing, it's going to first figure out the height. So I'm going to set up a variable for the height, and I'm just going to say bar dot get height, which guess what is a built-in function in the pyplot bar chart library, right? So what's the height of that? And it's going to grab that, store it as a value, and then we'll use that to do output to the screen. So the text that's going to go in at the top there is going to be based on a couple different parameters here. So I want to talk through this a little bit because, without getting really deep into GUI programming again, we're going to first figure out the X value of the bar. So in other words, where is it located from left to right? We're going to get that value. That's a function. So it's going to read that back to us. Then we're going to take the width of it and we're going to divide it by 2. And then we're going to take the height of it and add 1 to it. And then we're going to use an F string approach to display the height of it to 1 decimal place. Remember how long those decimals were? Like you can see them on the side there. And then we're going to center it. And then the font size will be 10, right? Or 10 points, right? So that's all one singular command here. All right, that's for doing that. Let me give you all this code in the chat here. You guys are anxiously awaiting it. All right. Next thing that we're going to do is we're going to add a title and labels. So I'm going to go back out to the margin here. So title, X label, Y label, and then we are also kind of basically setting up a little space for labels. So in other words, so that they fit, right? So in other words, what if the words are bigger than the graphic? And that's what this is kind of like. So I would call this, by the way, maybe optional, right? This little piece, but probably good practice, like if you were looking at examples. In the chat once again. So that's the title and the labels. Some blank lines. We're also going to throw in, and this is optional and I'd say subjective, right? Throwing in a grid so you can see where the stuff sits. Also, I'd say optional. The line style is just dashes. We're going to do it across the screen along the y-axis. And that alpha, by the way, if you guys are wondering what the heck that is, that's an opacity setting. So that means it's only 70% solid, meaning it'll be somewhat transparent, right? So it won't be as dark as some of the other stuff on the screen. Next thing is to display it. And then you'll notice a little addition here. Normally we just do show, but we want to make it a tight layout. I mean, we want to have enough space for everything, but we also want it to be as concise as possible so we're not wasting space. So that tightens up the layout. It's an automatic tool in pyplot, right? And these are the kind of little quirky things that you learn as you work with these tools a lot. And you can try it with or without so you can see the differences if you're curious, right? So here's that code. All right, last thing that we have to do is we're gonna print out the current values, right? So it's gonna show the current pressure readings, and I have a for loop for that as well. And once again, without getting really deep into explaining what we're doing here, I'm just kind of giving you the code just to speed up the whole process. But we talk about this data structure that we've never really used in any of our classes or instruction called an enumeration or an enum in some languages. And basically that's when you have data points. And in this case, it's referring to what? The pipe names. So these are our data points. And these are enumerated, meaning that it's a finite list of pipes, and each one has its designated value. So we're going to iterate through that, and then we're going to show the pressure values for each pipe rounded to 1 decimal place, and that should match up with the data points in the plot. Right. So that code in the chat. All right. So we have everything that we need at this point. I'm going to go ahead and also run this one. So here comes the runtime. And there you go. So I want you to notice all the little features that we have going on here in the output. And I'll make it a little bit bigger so it at least looks kind of nice. Notice how it automatically scaled the y-axis, right? Because that we had one data point that could go up to 110 and it ended up at 105.4, but we also wanted it to be have enough room for the text at the top, and it did all that work for us. So it like formatted it to 1 decimal place, indicated the PSI amount. The pipe names are at the bottom corresponding with each pipe. All the pipe data points are within the ranges that we set. The labels are clear. There's a title for the graphic. And I mean, it looks pretty good considering how little code we wrote. And yes, there are simplifications to this. We could really trim down a lot of this stuff. You can even make the font smaller or bigger or whatever. We are using default fonts, and I'd say relatively default font sizes. You'll notice the lines that go across the screen and how faint they are, right? And that's because of the alpha setting, where if I would set the alpha to 1, which is default, it means not opaque, right? And these would be black lines going across. Like right now, if you look really closely, you can see a very slight gray line where all those lines are put in. You'll notice that the grid line was placed after the bars were placed. So the grid lines go on top of the bars. If I would move this above where the bars are generated, then the grid lines would be behind the bars. So that was a conscious choice, really, to put them there so that they're forward. I don't know if that's good or bad. That's, I think, somewhat subjective, right? The data points here are, remember, also indicated at the very top of the graphic, so you see them. But you notice the visual, once again, I think is very helpful from the standpoint of like you can see where the data sits, and then you can see the actual value as well. So you have the graphic, which resonates with a lot of people pretty quickly, and you also have the specific data points represented as well if you don't want to look at it. Now, keep in mind, this is generated by a Python program, so that means every time I run this, right, and this is random data, every time I run it, the chart should look a little bit different. And you see the bars moving, right, and all getting different values every time I run it. And keep in mind, regular users see the graphic. They don't see the Python code that generated it. They don't know if the data is simulated or real. In this case, we're simulating the data, but we're showing, kind of the fluctuation that might happen in the real world with pipe pressure. It might vary by a few pressure points, basically. All right, so that's the second exercise. Now we're going to move on to the last exercise. We don't have a lot of time left, but we're going to get a start on it. And this one's a little bit more complicated because there's a little bit more of a background that goes with it. And the expectation here, by the way, is I'll help you get started, but the hope is that you guys finish it up on your own. One of the biggest challenges of this, real frankly, is weeding through all the data because the data sets are huge. All right. Very interestingly, when I first generated this assignment, it was right when the pandemic was kicking in. So it was really kind of a weird point in time. So let's kind of do like a little history lesson here. The pandemic started or was declared a pandemic really in the spring of 2020, right? And that I don't remember exactly when we went into lockdown, but I think it was like mid-March or something like that. Of course, COVID was a thing prior to that. They were catching on to the fact that like in China and other places, people were dying from it. They knew it was a thing. They knew it was an issue. And then they didn't think it was happening here, but then all of a sudden they realized, oh my God, it is. And then they started keeping statistics on it. And it's really interesting to look at the statistics because these statistics are right from the dawning of when this was going down. So like when we ran these data sets originally, we were all like, oh my God, the world's ending. There's a pandemic happening and we can't leave the house and you got to wear masks, and we were all freaked out, right? The people at Johns Hopkins, which is a big academic teaching institution, was keeping the official data set planet-wide. And I'm going to show you some of the data here. You'll notice I have a link here. And here's what I will also say about this assignment. If you have a different set of data for this to analyze, you can feel free to use your own data sets that you find, because you can find it in a lot of different places, by the way. But I think ultimately all the original data comes from the Johns Hopkins data, which I have linked up down here, right? And we'll look at that in just a second. But I wanted to start here because what they did is they used this tool called Tableau, right? And this is one of the tools that you guys will be learning in the data analytics program. And what Tableau is, it's a tool that takes tabular data, like a spreadsheet, a CSV file, XML file, a JSON file, database dump, anything like that, and then allows you to turn that data into visualizations. And I want you to notice here, the dates on the visualization start in January of 2020 and run up until April 29th of 2022. I guess that was the official end of the pandemic and they stopped grabbing data. John, I see you have your hand up.
Yeah, so I couldn't find data on those links. It could have very well been that I missed it, but I did find something directly from the World Health Organization, and I pasted the link. That's all.
Okay.
Just in case that helps.
Yeah, and you know what? This is one of those data sets that people will be studying for a while because it is so rich and robust, is a polite way to say it. And I think it's a really, really interesting data set in terms of like what we do, in this program. One of the things you'll notice about Tableau as a product is like once you create something in their software, and Tableau technically is a standalone piece of software that you guys learn how to use. That also generates through their website. If you wish, you can take your data dashboards that you build with their product and you can publish them to the web. And that's exactly how this one was done. It's made public. A lot of people publish their information this way. What's neat about it, and I don't know if you guys are picking up on this, is all the visualizations are interactive. So as you move around the visualizations, it shows the numbers. You know, notice, for example, you know, the dates. So like how many new cases they were finding. And then, you know, so in January, they were getting like 13,000 new cases a day, or by March, whatever. And then by July, it was 250,000. And oh my God, like, you know, all these like spikes. And you notice there's little ebbs and tides in the number of new cases, but holy cow, it went off the charts here. I'm not sure what that spike is, or, you know, who's reporting it. And then there was like a rapid decline, and then they stopped detecting it. But you notice when they stopped running the numbers, even where they stopped, that's how many new positive cases they were finding in one day. Right. So I think these are really astounding data sets. And they're like, yeah, the pandemic's over. So it's down to 600,000 a day now, you know. And then you start looking at the number of deaths. And this one, of course, is really troubling. This is how many people were dying each day. And there's that one data point that's really anomalous there. Anyhow, but it shows how many people were dying each day. And this is, I think, the global tracker. You can also switch to the US, right? And notice how it loads up the maps here. And then they have like, you know, kind of like these bubbles here, how many cases. And then they would update these numbers constantly. And you know what? All of these numbers, by the way, are data sets that are from tabular data files, like spreadsheet data, folks, CSV files mostly. And so in other words, John Hopkins, I'm not sure how they got to the center of it. I'm sure they must be like a key academic institution here in the United States for doing this stuff. But they started basically taking the numbers that they were gathering from around the planet, from all the different health organizations, and then sharing it in a few different spots. So this is, I'm going to go back, by the way. I think what's interesting about that is, you know, explore it, because you can see how what kind of stuff Tableau can do in terms of output. And I think that's really kind of interesting. Another really interesting website that a lot of people were visiting at that time is this one. And this one, and if I remember right, when I started reading up about this one, and I think I did it here, this was done, and I just want not to shock you guys, right? This was created by an 18-year-old high school senior, right? Just a kid in high school. And he tapped into the data set and then created this visualization that a lot of people looked at. And why? Okay, so this is not as graphical as what we were looking at, right? But if you wanted to look by country, the number of confirmed cases, deceased, how many per million people died. I mean, this is impactful data. And he goes country by country, et cetera, state by state. And he just like basically sorted all the data in neat little things, right? And once he had the setup here, he had probably, I'm going to speculate, it was probably a Python program that extracted the data on a daily basis and then fed it into the website. And every day when it got updated, this would update. And this is free, right? But he did have a little donate link up here. And the other thing that he did is he also created this map. And once again, this is very similar like Tableau, but not quite. Right? And this with code, but it just shows you what somebody that's motivated can do, basically, um, with the right technology in place and a little bit of wherewithal to put it all together. Ultimately, the data that everybody was pulling from comes from this GitHub link. And I want you to notice here, I'm already kind of deep into their repository. And it, when I first got this link, I'm like, I don't get it. And I had to like really kind of dig through it. And they have the data broken down by daily reports. That's global. This is daily reports for just the US. And then they have basically the time series data here, which basically, if you look at these CSV files that are listed, confirmed US cases, confirmed global, deaths in the US, deaths globally, and the number recovered globally. Those are the data sets here. And as you start to think about this, now you got to start thinking about what is it out of all this information you even want to put into a visualization. Are you more concerned with how many people are infected? Are you more concerned about the US or the planet? Are you concerned about how many died, how many recovered? But you see all the data points. And real frankly, when you start looking at these data points, so I'm going to click through to one of these files, and then I want you to see what it looks like. So this is the raw data that's in the file. And this is a preview. So this is not, I don't know if this is all the lines in the file. I could probably assume that it is. But if you look at this data really, really carefully and try to figure, okay, like what is all this? And it says, we can't make this file beautiful and searchable because it's too large. It's a large data set, and this is updated daily. So the first row in the file, right, you can tell this is a CSV file because all the data is separated by commas. And apparently there should be a data point here. So they list the country, that's the second field. Some places have states, some don't. That's why there's nothing before the first comma on some of these. Then they have the latitude and longitude. That's how they can plot it on a map, by the way. And then the date the data was collected. And you'll notice at first, well, I guess this is daily starting on January 22nd of 2020. And the data set continues, right? So you can just keep going across here. It continues all the way to March 9th of 2023 is when they stopped collecting the data. So it went beyond what we talked about. And what was this file? This was confirmed cases. So confirmed infection by test, right? That's what this data set is. Now I'm going to go back to 100% zoom on this. And then for any of these data files, you can download the data. So if I click download here, this is going to download the CSV file. And now you can see it in my download folder. It's fairly large, but it attributes to Excel, so I can look at it in Excel, right? And so let's do that. I'm just going to show you that I can pull it up in Excel, let it load up. And of course, it goes to the other screen. I'm trying to see if I can grab it here and move it. It's underneath a bunch of stuff. There we go. And so this is how it looks inside of Excel. Notice many columns, right? And as you move across, we go through time. So you have this one, once again, dates, latitudes, longitude, the place, and then how many confirmed cases they had going through time. And I think this is really fascinating because, of course, we're always concerned with ourselves more than anything else, pretty much. If we look at the United States here, and is it even in there? Okay, so United States is, I'm thinking, not included in this data set. That's kind of interesting. So this is for the remainder of the planet. Interesting. And I wonder why they did it like that. So the United States is completely separated out. Okay, so that's a concern. But if, let's say, you have a particular interest in plotting out the data for one particular country, that's in this data set. what might be more interesting, and we look at like the US data set. Okay, that file is too big right now, but I'll download it. Okay, so there it is. And I'm going to pull in the US data set. So it takes, these are large. Okay. I'm asking it not to convert my data. It's asking me if it wanted me to convert data, and I said no, please don't, leave it alone. And um, I think this is pretty fascinating. So like they have this broken down in different kind of detail. So here for the US, I want you to notice they have it broken down by county. For every county in the United States, we have all the data for that. And so these are like Alabama numbers. I guess we could scroll way down to Wisconsin here somewhere, right? So here's Wisconsin numbers. Probably 72 counties in Wisconsin, Milwaukee County, where I'm at. And then you can kind of, if you want to do it like this, so you can see it. And then you can see, you know, date wise, when the numbers really started jumping up is kind of the point, but you can see the rate of increase. And so one of the challenges here is you're like, oh my God, how am I going to plot this? What am I going to plot? Okay, so this is one of the challenges of the assignment, by the way. So getting to the data source is one thing, but what do you do with the data once you can access it? And then think about these people who are creating the Tableau visualizations or that website that kid made. You have to make choices. It's like, what data are you showing? How am I going to show the data? How am I going to visualize the data? It's all those pieces that go with it. So if we look at the assignment description, then I want to take us back there. All right, so I want you to notice here, so there's flexibility on this one. It says create a program that plots the data in a format of your choice. Logical choices for this might be a bar chart or a line graph. I think either one of those could work. Include data for both confirmed infections and confirmed deaths. So wherever you're doing it for, if you're picking a country or you're picking a county or a state, however you want to do that, that's on you. But you got to process the data. So you might not want to do that for every country on the planet. You might just want to do it for, I don't know, Racine County, Wisconsin, right? So confirmed infections, confirmed deaths, those data sets are in there. A title that describes what is shown, labels for the X and Y axis. We have enough examples of those now, and include a legend of the data. And I will show you how to do that next time, by the way. And then format the graph so it's appealing visually and easy to read and understand. All right, so you're going to be doing this in Python, by the way, right? So you're going to pick an approach. If you want to do a bar chart, that might be a way to do it. If you want to do a bar chart and a line chart, or however, but if you're comparing two data points, it's going to be a combination of values. Now, I know that you can easily take data and throw it into Excel and create bar charts, right? Without a lot of effort. But when you start with a big raw data set, now you're confronted with some issues like the ones I'm about to show you. So one of the concerns, of course, is, all right, well, I have all this data and it's all in a row here. How do I process just that row? Well, I got the row highlighted. So maybe one way to do it is, how about I make a copy of the spreadsheet? And I'm looking at, the raw version of the data here. And actually, maybe that was not the smart way to do it. Let's not do it like that. Okay, so let's go up here. And maybe I need to look at, it's hard to scroll that many lines. Right? But this first field is probably pretty handy. So I might create a new spreadsheet and paste in that row. So I have all the dates and all the headers. And then I can come back to my Wisconsin data, wherever the heck that is. And let's say, just for example, we're doing Racine County, which is this one. I'm going to copy that row and then place that here. Right. So now all the dates and the confirmed infections are basically here, right? So you have this like data set that really is, you could think of it like, if you're thinking of it in Python terms, two lists of data. So I could then sanitize this data in the following way. I'm not really concerned about this data because I know it's Racine County. So I could basically remove those columns. And I'm kind of giving you this as an example. And then I'm left with two data sets, right? And so what I could do with this is I could take this information, and I'm just going to show you this. And before you guys are saying you're destroying all your data. Yes, I am, but I can always download it again. Just remember that. I can take this and save it as a CSV file, right? And you see it already kind of picked up the name. And I'm going to, just call it something else. I'm going to call it Racine. This was confirmed cases. And we'll just call it a CSV. Yeah, I'm putting it in my downloads folder for now. But now I'm going to go look at that file. So I'll bring my tool over here. And probably going to be up at the top here somewhere. And then I'm going to go ahead and open that. And yeah, it'll open up in an Excel just the way it looks. But in reality, when I open up that file, and I'm going to go back to it one more time, and I open it up with like a text editor, this is what it looks like in a text editor, right? So this is, I want you to notice one line of code. This is all line one are all the dates. That's just all the dates. And then I have all of this as basically all the confirmed cases for that county. Now, one of the challenges, okay, so when you're writing your code, is it's helpful to have data that's broken down into lists. What would it take for me to convert each one of these into a list? And I want you to think about that. One very simple solution in Python would be, for example, I could just have one called dates. You notice I'm just typing right in the CSV file. My point is, a list in Python is basically square brackets around comma separated values. But I want you to think about this. Are dates going to come in as numbers or text, or is that going to come in as a mathematical equation? Right. If I put 1/22/2020 into a Python list, what is Python going to do with it? Well, it's going to divide 1 by 22 and then divide that result by 2020 and give me the numerical answer to it. That's what it's going to do. So all of these need to be converted to text. So here's a job, by the way, a valid job for an AI engine. So for example, I'm going to copy all this, and I don't know if it's going to allow me to do this. And it's probably better to have it here. It's probably better to save it as a CSV file. And I'm just going to go to an engine like, for example, ChatGPT, and that's just one of them. And I'm going to say, can you please convert this CSV file to a Python file with two lists of data, the first being dates, the second being a count of cases, an int, and name the first list dates and the second list cases. And I want to attach my CSV file. Right, that's the one I just created. And I want to make sure my prompt is good. The first list being dates, the second list being a count of cases, an int. And I'm going to say text for the dates. All right, let's see what it does with it. Now, the point of this is you could do this manually, totally could. It's not that hard, but can you imagine? You saw how many dates there were? This spreads over 3 or 4 years. And for each one of those dates, you would have to go in and put double quotes around each date, as well as the square brackets on the end. And let's see how it did. So I let it do the work for me. And the point of this really is, let's see what it did with it and notice what a beautiful job it did. So it created a list of dates. Notice the square bracket at the beginning. And then for each date, it put quotes around it for me. So this is one of those things, like, do you want to sit there and put quotes around all that data? No. Right? And the same thing with the cases. But now that they're in Python lists, these two data points very easily can be fed into a Python program to plot it on the screen. Given the fact that we're working over a certain date range, so these are the confirmed cases, we could also have confirmed deaths, create that as another list, and then we can plot it all on the same chart. Right, so that's kind of the breakdown of how. So next week, I'll show you how I did that. And I think it's a very interesting data set. So the recording stops here, folks. And we'll get the solution to this next week. But you should give it a try on your own.